Good morning to everyone. Today, we'll be discussing linear regression, an important algorithm that has been used in machine learning, especially for prediction tasks. This can be only used for prediction. It cannot be used for classification. This linear regression, which has been used for prediction, is not only used in computer science domain, but it has also been used in multidisciplinary to complete the prediction task. So the agenda of today's lecture will be, first we'll be looking into the algorithm. Second, the illustration. We'll just take a sample of 4 to 5 data points and then just work out how the algorithm works on the real data. And third, we'll be seeing about the programs of how it runs on the Google Colab or Anaconda or Jupyter Notebook. Okay. So first, starting with the algorithm, the first step in algorithm is that we have to take the input value. So when it comes to algorithm, the step one is we have to take the input values where we can give capital X is equal to x1, x2 up to xn, because the number of input features may vary depend on the real-time problems. In some data sets, there may be 10 attributes or features. In some data sets, there might be more than 100 attributes or features. So we can give in generic that it is x1, x2 up to xn. And next in step 2, we have to create a hypothesis. The hypothesis means that it is not going to be an exact value. It is going to be a value based on some random assumption. So the hypothesis is that y prediction, which is equal to, since it is a linear regression, we'll be following the line equation formula. What is the line equation formula? Y equal to mx plus c. But here, we'll be not taking mx plus c. We'll be taking as x1 and the weightage of x1 plus x2 and the weightage of x2 plus up to xn, the nth value of the feature and its corresponding weight, plus along with some bias. The reason to add bias to the linear equation is that when we solve the real world problems, it might not always be a pure data. We might have some noises and there may be some interpretation in the data. So if we give the exact value alone, the model might tend to overfit or underfit. So in order that the model must not be biased to the data, we are adding some sort of error that is biased to the linear equation. And in step 3, we are going to compare the original y value and the y prediction. So based on this, the step 4, we can calculate the error. Error, we have two types of error in linear regression. One is mean absolute error and another one is mean squared error. We could either take absolute value or square value. Why? What is the reason behind taking the absolute or squared value is that, suppose if I'm having 10 data points in my data sets, okay, for 5 of my data points, I'm getting negative value. For 5 of my data points, I'm getting positive value. So when I sum up all this, what happens? The negative value and the positive value cancels out, and it might cheat the model that there is no error in the learning. So that error, it should not occur. So that's why we are either taking absolute, where we are converting the negative value to the positive value, and or either we are taking squares. So automatically when we take squares, even there is negative value, it will be converted into positive values. So next we have calculated the error. Now we are checking if the error is very large. What we have to do is we have to optimize the algorithm, optimize the model. So how can we optimize the model is that there are 3 methods in optimization algorithm, where the general optimization term is using gradient descent. So in gradient descent, we have 3 types. One is the stochastic gradient. Second is the mini batch. And third is the batch gradient. So what is the difference between these 3 is that in stochastic gradient, each data point will be taken and the weights and the biases will be updated. In mini batch, what happens if I'm having 1,000 data points in my data sets? The data modelist or scientist can split the data sets, whole data sets into their desired size, like 10, 20, or 40. Batch gradient is that I'm taking my whole data set at a time and updating the weight and bias based on the whole data set. So now I have optimized my model in order to reduce the error. Next, what I'm doing is that I'm repeating the step 2 to step 5 until my error converts. Until I'm getting low error, I'm going to keep on repeat the step 2 to step 5. So once my error has been reduced, now what I'm going to do is that I'm going to evaluate and save my model. So this is the algorithmic approach of how the linear regression works. So first we have to take the input values. Next we have to create a hypothesis, and based on the hypothesis we have to compare the original y value and the y prediction. Next we have to calculate the error. The error can be either a mean absolute error or a mean squared error. Next, if the error is too large, then we have to optimize the model using a stochastic gradient or mini batch or batch gradient. Next, we have to repeat the step 2 to 6 until it converges, the error converges to a smaller rate. Once the error converges to a smaller rate, we have to evaluate and save the model. Then we can give new values and predict the model. I hope the algorithm is very clear. Next, we shall move on to the illustration part. Now, here I have taken a simple data set where the first column defines the age of a house. The first column is that the age of a house is 20 years old. It has only one floor and it has 3 bedrooms. So the cost of this building which has this feature is that it is $400. The next row defines that age of a house is 15 years old. It has 2 floors and it has 2 bedrooms. So the cost of this particular building is $600. And in third data point, we have a building with age of 22 years, which has 2 floors and 2 bedrooms. And the price of this particular building is $200. Now, this is the given data set. Now, we have to find the linear regression for this. According to this algorithm, I'll show you how this algorithm works for this particular type of data. Okay. So, in step 1, what we do? We have to take all the input points. So, considering first input, what is that? So, here x is equal to, we'll have age and the floors and the bedrooms. These 3 are the input features. So what it will be? It will be x1, comma x2, comma x3. Since we have only 3 features here. And second one, we have to create a hypothesis. So hypothesis will be created based on our assumption. So here, the y prediction is equal to the weightage given to the first house. Since it is the model is in learning phase and we have initiated the hypothesis, we can give some random values. The values must always be some small values like 0.1, 0.2, 0.3, 0.5, so that the model will be able to learn slowly and accurately. So the weightage of the first attribute of house is 0.1 into x1 plus the weightage of the second attribute, I'm taking it as 0.2, which is x2. And the weightage given to the third attribute is 0.3, which is into x3. And what I have to do, I have to add a bias along with this line equation. Why? Because my model might have some noise in the real world data. So that's why let's have 0.5. Okay. So now I have created a hypothesis. And third one, now I have to compare my y predict and my original value. I have to calculate the error based on this. And fourth one, if I have an error, I have to optimize it. And then fifth, I have to save the model. Now, let's do one thing. Let's have this real data. Now, I have taken the hypothesis here. Now, based on this hypothesis, let's calculate the y prediction and the y error of this particular model. I'm extending this table to calculate my y prediction. So let's have y prediction here and identify the value. So here what I have 0.1 weightage given for my first age. So what I have to do is 0.1 into 20 plus 0.2 into 1 plus 0.3 into 3 plus my bias. So now I have to calculate the values. While calculating the values, I have calculated the values for remaining two data points where, see, now when we compare the original original value and the predicted value, there is a huge difference because the model have not learned the exact weight and biases for the data. We have initially randomized to some random values. So now what happens is there is a huge error. The model might needs to optimize. Here again, I am extending this table to calculate the error to you. So for mean absolute error, what we do? The original value minus the predicted value, absolute of the original value and the predicted value. For sum of squared error, what we do is that we have to uh, have the difference between the original y value and the predicted value. So here I'm calculating the error for all the three models. So how do we calculate the error? If it is mean absolute error, we have to calculate 400 minus 3.6, the absolute value. So we have to take the absolute value of 400 minus 3.6. If it is sum of squared error, what we have to do? We have to take 400 minus 3.6. It is squared error. So in both these errors, what happens is that in here, if there is a negative value, when it comes out of this absolute, it could have converted into the positive value. And here also, if it is a negative value, what could have done when we take squares, it could have converted into positive values. There is no any rule that we should have the difference between y and y prediction. We can also use y prediction minus the y value, because since we are using absolute and the squared error, both might work out for calculating the error. I hope now the mathematical intuition behind the linear regression is clear. Next, we will move on to the problem of linear regression. Today we'll be using Google Colab to do our program. As a beginner, it is always best to use the Google Colab. You can also use Anaconda or Jupyter Notebook, but Anaconda takes a huge RAM space and makes your system slow. So as a beginner, it is always better to use Google Colab. So first time when I log into Google Colab, I have to take this new notebook. It asks for you to sign in. So you can give your Google sign in as well to log in into the Google Colab. The whatever program you do in this Google Colab, it will get stored in your drive. So next we are logging in using our Gmail. Here I have given percentage matplotlib library in inline and importing the matplotlib as PLT for plotting my data and seeing. In that particular matplotlib, I'm using Seaborn White Grid as my style. And next I'm importing NumPy as NP. The NumPy is used because it is needed to do some mathematical calculations like calculations with arrays, matrices, etc. Okay. To run this particular code, what I can do, I can simply just click on this play button, or I can give shift enter to run this particular block of code alone. So the main advantage in Python is that it can run the program in each cell so that the debugging becomes easy and faster. So next I have to generate some random values with the help of this numpy for creating my data points. Random state. Since I have used it is auto generating code, it gives me the specific values. I'm just giving tab. This random state specifies that it generates random numbers each time I run this code. So yes, see here, it has given the X and Y and it has plotted those values also based on some random values. Next, from the sklearn, I'm going to implement the linear model which is being used for linear regression. And I'm going to use this linear regression model and save it. Let's see how this works. Yeah, I'm used this linear regression model. This linear regression model is been already trained and the error has been optimized and it is available in the form of package. We can use this linear regression for our own data set. So next we can fit this model for our data points, which is x-axis. Here we get the automatic code and we can just run and see whether this works fine. Yes, the model is fitting exactly for our x value and y value. Next, xfit is equal to numerical python dot line space of 0, 10, 1000. So this value I'm giving it that it has to take 10 values. If I'm having larger data sets, I'm giving tab. Getting error. So I'm taking this xfit and yfit and plotting the values. See, based on my input data, the linear regression model that has been saved has been created an exact linear regression model which optimizedly fit all the data points that is available in the input. Now, what we have to do is we have to check the weight and bias of this particular model. I'm going to print and see the weight and bias of this particular model. Model slope, which is the weight, is being given as model dot coefficient of 0. And similarly for the intercept as well. See, the model coefficient and model intercept are the weight and biases that is essential for the model. So now the weight for my model is that 1.9 and the bias for my model for this particular model is minus 0.9. Now let's check for some random value how this data works. So I'm giving here some random value and checking how this data works. 0 point, I'll just change this values. NP dot of x comma 1.5 comma minus 2 1. So here I have created a simple linear regression algorithm or a program. So first what I have done is I have imported the matplotlib library to visualize my data point, and then I have imported the numpy to do some mathematical calculations. And next is that for my data points, I have created a random generator to generate 50 such points for in the x-axis and the y-axis. And this is the equation I have created to create the x data points, and this is the equation I have given to create the y-axis. Now I'm plotting the points x and y and z. Now from the graph, we observe that the dependent variable and the independent variable are in linear relationship. if the X value and the Y value are growing linearly. And next, since I know I'm going to use the linear regression, I have imported the linear regression from the packages. This linear regression model has been trained by a data scientist and it has been available as a package already. I'm going to use that linear regression and fit for my data points. So I have taken that linear regression. Now I'm going to fit that particular data point to my x-axis and y-axis. Next, what I'm going to do is that I'm going to create a new linear line for those particular x and y-axis data points. See, using that linear regression which has been created by a data scientist, I'm getting exactly a good linear line which optimizely fit all those data points that is available in my data set. Next, I'm going to print and see what is the slope and intercept, which is the weight and bias of this particular model. The particular model's weight is 1.97. We have only one input x. So they have calculated only the slope for that particular input. And the bias here is minus 0.9. Next, we are calculating some random state. Using that random state, we are trying to test a model, and when you are testing a model, it is exactly giving the more or less similar values where we have taken for our output y. So now we'll see a basic linear regression problem by taking the dataset that is available in the Kaggle. You can download your dataset from Kaggle. There you have a variety of datasets according to the problem statement. I have taken a Toyota dataset that is based on the age and fuel and some other features. We are going to calculate the price of that particular vehicle. So now I have downloaded the dataset and I have to import it to this particular Google Colab. See, I can give the arrow mark here. You'll be having like this, the Google Colab. When you open, you have to click this files folder and you'll have a up arrow mark. When you click that, it will ask for the destination where our data set is stored. So you can click on that and give open so that the data set will be imported here. Here, the first step deals with I'm importing the necessary packages that is needed to create a good linear regression model. So first one is the NumPy. NumPy is used for calculating arrays, matrix addition, and few of the mathematical calculations. Next is the Pandas. Pandas is used for the data manipulation and visualization. TensorFlow. TensorFlow is used for the linear regression models where we have when we go for higher dimensions. Next, we are from TensorFlow, we are importing the Keras packages, which is necessary to implement the and split the data sets based on the training and testing. Here we have few packages from sklearn to split the data set to train and test and have the standard scaler. Standard scaler I'll explain you later while doing the program. And next is the mean square error for calculating the error. Next is matplotlib to visualize the scatter plot. So now I have given all my necessary packages that is used for the program. And when I run this cell, it runs perfectly well and I've got a green tick. Next, I'm moving to data set. I have to take my data set, which is readof_CSV. So now my data set is named as toyoto.csv. It is here. I need to give the path of this particular data set. I can simply right click on this and give copy path and keep here and paste it. So now when I run the cell, it gets me tick so that the data set has been perfectly imported here. Next, what I'm going to do is that I'm going to print and see the shape of the data. So now here I have 1, 4, 3, 6 rows and 11 columns. 11 columns specifies that including the output. We have 10 features and 1 output in this particular Toyota dataset. Next, I need to view and see what are the features that is available in this particular dataset. I can give dataset.head. So that here I have serial number, price, age, kilometers, how many kilometers the vehicle has run, the fuel type, HP, mid color, whether it is automatic or not, the CZ, doors, weight, etc. Okay. So next, I'm going to give the data pre-processing step. I'm going to find what are the missing values that is available in the data set. So see here, among all the features available, fuel type and met color has this much type of null values. So the fuel type has 100 null values and the met color has 150 null values. So what we have to do is we have to drop this null values, or we have to use standardized form to fill some values in that data points. So now what I'm going to do is I'm going to drop all those data set under is equal to, I'm going to drop all those null values and print and see, so that my initial data points were 1436. Since I have dropped the null values, now it has reduced to 1200 data points. Now what we have to do is we have 1200 into 11 features. Now we have to split the data set into training and testing. So we can give X is equal to data set. So before getting into splitting the training and testing, I would like to take what is the input I'm going to give and what is the output I'm going to give for this. Cleaned, it is going to be, I'm going to take this age alone. Among this all features tab, I'm going to take the age feature alone. Age feature alone dot values. The price is going to be the output. Now, among all those features, I have taken, it's a, so I have taken the age as my x-axis and my price as my y-axis. Now, age is the independent variable and my price is the dependent variable, which completely depends on the age of the vehicle. So, based on the age of the vehicle, the price differs. Now, I'm going to split. So, x train, comma, x test, comma, y train. So, here, the size 0.2 denotes that 20%. The training set will be 20% and the testing set will be 80%. The random state is that each time we run this model, it will randomly split the data points for the training and testing. The same data points will not be available each time for the training and the testing. Now this exactly works. So now next what I have to do is I have to do the normalization. I'm using the standard scalar to transform my x and y. So this also works perfectly. Now next I'm going to compile my model using the Keras. It is the sequential model. What is the sequential model is that one after other. It's going to happen one after the other. And next is the model dot. I'm going to add few layers to this. I'm getting. So here I have created a model using the sequential in the sense it is one after the another. Next, for the input, there is only one dimension. I have taken only age as among all the features available, I have taken only age. Next, the dense layer says that each layer is mutually fully connected to the other layer. And the output is also one dimension. I'm having only one output. The actuation function is the linear equation that I'm going to use. Now I have created the architecture of my model. Next, I'm going to fit the model. I have to use X train, comma, Y train, and specify how much epochs it must run. For example, I'm giving bad size. This epoch defines how much iteration the model must run. The batch space specifies if I'm having 1,200 data points, it should take 30 to 32 data points and learn the data. The model must learn the data. Here I'm having epochs. Let's compile. Oops, sorry, I forgot to compile the model. So now I have created the architecture of my model. Next, I have to compile my model. So in compilation, I have to define what optimizer the model must use and what error it must calculate. It must calculate using the mean absolute error or mean squared error. Next, I'm going to fit the model. Model dot fit of. For fit, I'm going to use the X train, Y train, how much epochs it's going to take, the batch size. So I have given 100 epochs. You can see that is the loss is very huge. So we have to optimize. The optimization technique is a separate program. As of now, we'll just, we have trained the model and we have find out that it is giving a huge error. Next, we can predict and see how well the model is giving the answer. So it is going to predict based on the X test values. Now next, I'm going to calculate the mean squared error, which is equal to mean squared of. So the error rate is typically huge. In in order to reduce my error, what I have to do, I have to apply some optimization technique like stochastic gradient, mini batch or batch gradient to reduce this error. And what a good data scientists do is that they reduce this error using some optimization technique and they create a better linear regression as a package. So we can use this package and predict the data for our new data points or some real world problems. This particular package, linear package, we have used in our earlier program. So we have to next step is to use the stochastic gradient. I hope this program was useful for you and have a useful insight based on how this linear regression is being used in program. Thank you.